Many buzzwords are being thrown around today with regards to analytics and big data. Let's try and break that down a little bit. When we are trying to transform data for insights to make decisions, this falls under this giant umbrella of business analytics or data analytics, depending on how you decide to frame it. It's important to understand that anybody who's really working with data could be considered a business analytics or data analytics person. It's kind of like the buzz term that's going on right now. So depending on the function that you have and how detailed you are, will really begin to separate you in terms of that basic data analyst, all the way up through business intelligence specialist, all the way through a data scientist. Business analysts and data analysts will use a number of different tools, such as Excel, which will be exclusively used for this course, R, Python. Both are computer programming languages that are very, very good for advanced statistical processing, as well as some data science and machine learning and artificial intelligence. RapidMiner, which is a graphical tool to allow you to do some of that. SAS, which is also a programming language, is very proprietary in terms of what it's been used for, and it's been made more freely available. And SPSS, which is also a graphical interface that will allow you to create statistical measures and do some statistical analysis. Generally, business analysts will use very simple methods such as descriptive techniques and some slightly more advanced techniques such as regression, ANOVA, and time series. When you get into more data science, you're taking more advanced courses, you'll be doing things such as neural networks, support vector machines, and decision trees. The amount of data used can vary based on the need of the organization and the level of analysis, as well as the capability of the analysis and the technology being utilized. What we mean by that is certain tools can't work with a lot of data. So Excel is one example. You're going to be limited in the amount of data that you can churn, both because of Excel as well as because of the computer. More advanced techniques will require something like R, Python, or even SAS in order to churn through a lot of different statistical algorithms and get you the results that you're looking for, and they may have to be run on more powerful machines. Quantitative methods are generally statistical methods that provide insights such as predictions or can identify differences between groups for the purposes of these value insights. Managers may use these methods to build models for optimization or make decisions about projects and future strategic directions. We may want to optimize our staffing levels, or we may want to optimize routes that are done by various trucks and going from store to store, distribution warehouse, and so forth. One of the classic examples is Amazon. Amazon knows the products that people want to buy and makes sure that the products are in the warehouses close to them so that they will get it the next day. The aggregation of data and model building will enable managers to determine the most efficient reallocation of resources, provide more focus on types of customers to identify those operational efficiencies. So business analytics, therefore, will provide a competitive advantage for a company as well as help meet regulatory issues or uncover deficiencies within an operation. For those of you who study management principles, you're going to be familiar with this concept from Porter of competitive advantage, because that is one of the things that companies strive to do, gain a competitive advantage. And because data is proprietary and the analysis is proprietary to your domain or to your company, it can become a significant competitive advantage. Considering that the maturity of analytics within an organization doesn't happen overnight and is a phased approach, we have these 4 levels of analytics. The first level is descriptive. If we're doing some basic descriptive level analytics, simple metrics, averages, see what's happening year over year, month over month, well, that's in the business intelligence realm, and it's what we call our level 1. Moving into a little bit more, we have an enhanced descriptive where we can provide rationale for what is happening and identify possible causes. We might use some additional techniques to help us do that, but that's a level 2. And when we get to predictive, we have a level 3, which is how factors affect business operations and predict what will happen. We will actually create these predictive models using machine learning algorithms and artificial intelligence algorithms to actually give us that result. And we have prescriptive models which can prescribe what will happen and even simulate various events that will occur. And this is this spectrum between business intelligence all the way out to data science. So, as we said, descriptive analytics focuses on a variety of analytical techniques to describe what has already happened. Standard reports and charts such as year over year revenue or sales by customer are all examples of descriptive analytics. Predictive analytics uses techniques to provide forward looking prediction and are generally more complicated in nature and require more data. Prescriptive analytics will focus on the what if of analytics. It enables analysts to prescribe different courses of action and provide results based on a number of environmental situations that have yet to be seen. Now, big data is a relatively new term in the industry in comparison to some of the other things. We're looking at around 10 to 15 years where the concept of big data has emerged. And it attempts to differentiate standard data analysis with a more robust set of analysis using greater amounts of data and more rapid analysis. The focus on big data is large quantity of data, speed of data collection, and the analysis, as well as the variety of different formats to get the analysis, such as text, audio, and video. There are four main components to big data known as the 4 Vs. You're going to have a lot of volume. Generally, these are larger than normal data sets, larger than anything we would do in this session, usually in the terabytes or greater range. Variety will come from different sources and different data types. So we might be mixing tabular data with audio and video to really get some more insights into what's going on. Velocity focuses on the speed at which each data point is collected. The veracity and validity is that the data must be valid and accurate. And as such, we want to make sure that what we believe it means is what it truly means.